Hello everyone. Welcome to the solution of LeetCode problem 39 named combination sum. In this problem, we are given an array of distinct integer candidates and a target, and we have to return a list of all unique combination of candidates where the chosen number sum up to the target. And fortunately, we can return the answer in any order. There is a condition that we can choose any number from the array unlimited number of times, but we should not include any other duplicate combinations. Or we can say that we have to include only the unique combinations. Now let's analyze the first example. In this example, the array contains 4 elements, which is 2, 3, 6, and 7. And we have to make target 7 by using these elements. We can include this element any number of times. Suppose in the first combination, our vector contains 2, 2, and 3. Here, we choose 2 2 times and 3 1 times. And summation of all of this element is 7. So this is one kind of combination. And similarly, if we take only element 7 in our list, this will also end up to the summation to 7. So this is another types of combination. So we can say that for this example 1, there are only 2 types of combination. Now for the example 2, the input array contains 3 elements, which is 2, 3, and 5. And we have to make 8 by using this element any number of times. One of the possible solution is we can take 2 4 times and the result will be 8. Because if we add all of the 2, then the result will be 8. The another possible solution is we can take 2 1 times and 3 2 times. So in this case, 2 plus 3 is also equal to 8. Anyways, another possible solution is we can take 3 1 times and 5 1 times. So the summation of them is 8. So 3 5 is also one possible combination. Now finally, let's understand the constraint. In the constraint, the input array length can be in between 1 to 30. And each of the array element can be in between 2 to 40. And it is ensured that all of the array elements are distinct and the target can be in between 1 to 40. I hope you understood the problem. Now let's move on to the solution. Now, if we analyze the structure of this problem or the problem definition, we can clearly find that for each element in the array, we have two choices. Either I can include it or I can completely ignore it from the combination. So when we have this kind of choices, mostly this kind of problem can be solved using backtracking, and the decisions can be explored using the decision tree. Now, let's analyze the decision tree of this problem. At first, our input contains 4 elements for the test case 1, which is 2, 3, 6, and 7, and our target is 7. Now, it is the root of the decision tree, and currently we are pointing to the element 2. Now, for this node, we have two choices. Either I can include 2 or I can completely ignore it. If we include 2, our temporary vector will contains only the element 2. If we ignore the element 2, our temporary vector will be empty. Now, for this 2, we have two choices. In this case, we can include any element any number of times. So here, we can include another 2. So if we include another 2 from this node, then our temporary vector will look like this. Here, 2 2s are available. And there is a condition. In this path, we cannot include any 2s because this is the main mechanism of eliminating the duplicates. Because in this path, we have included 2 2s. So it doesn't make any sense to include 2 2s in this path also. So in this path, we can completely ignore the second 2 and our input vector will remain same. Now from this 2 and 2, we can include another 2 here. By doing so, our temporary vector will look like something like this. It will become 2, 2, and 2. And in this path, we can completely ignore the third 2. So our temporary vector will remain same, which is 2 and 2. Now, for this 2, 2, and 2, we can include one more 2. But wait, if we include one more 2, the summation will become 8, which is greater than our target 7. So, it does not make any sense to explore the graph further from this point, because the summation will also exclude the target. And if we include any other element except 2, which is 3, 6, and 7, our summation will also become greater than 7. So we cannot explore this path as well. Now, for this 2 and 2, in this part, we should not consider the third 2 or should not take any other 2 because we have already explored the 3 2's in this path. So it doesn't make any sense to explore any 2's here. Instead, we can take 3. Now, if we consider 3 as our element, our temporary vector will contain the value 2, 2, and 3. And fortunately, their sum is equal to 7. So, this is one kind of solution. And from here, we have another choice. We can simply ignore the 3. So, our resultant input can remain same, which is 2 and 2. Now, as we are ignoring 3 here, our remaining element is 6 and 7. But if we put 6 or 7 from this node, then our summation will exclude the target. Suppose we are putting 6 here. So our summation will be 2 plus 2 plus 6, which is 10. And if we put 7 here, our summation will be 2 plus 2 plus 7, which is 11. So both of them are exceeding the target. So we cannot further explore anything from this node. Now, for these 2, in this path, we should not include any other 2 because we have already explored the decision tree using the 2 2's. So it doesn't make any sense to use second 2 here. Instead, we can take 3. So by using 3, our current vector will become 2 and 3. And we have another choice. We can simply ignore our current 3. So our temporary vector will remain same, which is 2. Now, in this node, we have already included 1, 3. So we can include any other 3 or 6 or 7 here. But the summation of this node already become 2 plus 3 is equal to 5. If we include 3, then our summation will become 8. If we include 6, our summation will become 11. And if we include 7, our summation will become 12. So it doesn't make any sense to include any other element from this node. So we cannot further explore it because if we include any other element, the summation will exceed our target 7. Now, for these 2, we cannot include any other 3 here because we have already explored the solution using 2 and 3 previously. So we have 6 and 7 remaining in our choice. But if we include 6 in these 2, the summation will become 8. And if we include 7 in these 2, our summation will become 9. Both of them are exceeding the target 7. So here we can see that we cannot include 6 or 7 from these 2 again. So in the left portion of this decision tree, we have completed the iteration and reached the base condition for each node. Now, for this empty vector, we have choice 3, 6, and 7. We should not consider 2 as a choice because in this path, we have already ignored 2. So it doesn't make any sense to include 2 here once again. Now, from this empty list, we can include 3 here. And our list will contain only the element 3. Or we can simply ignore the element 3 and our list will become still empty. Now for this element 3, we can include any other 3 here. So by considering the 3 two times, our list will contain 2, 3 here. And their summation will be 6. And we can simply ignore the second 3 here. By doing so, our vector will still remain same, which is 3. Now, from this 3 and 3 vector, we have 3 choice. Either we can include any other 3, 6 or 7 here. But the summation of 3 plus 3 is 6. And if we include any 3, 6 or 7, our summation will become greater than 7. So we cannot explore any other path from here. Now, from these 3, we cannot include second 3 here because we have already included it here. Now we have 2 choice. We can either take 6 or we can either take 7. So if we take 6 or 7, our summation will become greater than 7. Because if we take 6, our summation will become 6 plus 3, 9. And if we take 7, our summation will become 3 plus 7 is 10. Both of them are greater than 7. So we cannot include any other value here. Now, for this empty list, we have 2 choice. Either I can choose 6 or 7 because we have already excluded 3 here. So we have 2 choice remaining. If we include 6, our list will contain the value 6 here. And we have another choice. We can completely ignore the 6. So by doing so, our list will become empty again. Now, from this 6, we have 2 choice. Either I can take one more 6 or I can take 7. But by taking one more 6, our summation will become 12 because 6 plus 6 is equal to 12. And by taking the 7, our summation will become 6 plus 7 is 13. So both of them are prohibited because both of them are exceeding our target. So we cannot take anything from here. Now for this empty list, we have another choice. Either I can take 7 or I can ignore it. If I take 7, our current list will contain the value 7, or if I ignore the value 7, our current list will become still empty. Now we have also reached another result because the summation of this 7 is exactly equal to the target. Now from this empty list, we should not explore anything because in this path, we have ignored 2. In this path, we have ignored 3. In this path, we have ignored 6. And in this path, we have ignored 7. So it doesn't make any sense to explore anything from this node again. So we have finished the building of this decision tree. And by applying this algorithm, we can eliminate the repetitive combination. I hope you understood the algorithm. Now let's move on to the actual code. In this code, at first we are given a function named combination sum. The first parameter of this function is the input array. Then the second parameter of this function is the target. And we have to return a list which contains all the combination. At first, we have to apply the sorting function because by applying the sorting function, we can explore the decision tree with optimal strategy. Anyways, then we have to declare a current vector which will temporarily hold the result, and finally our result vector. Now we have to recursively call a backtracking function. The first parameter of this backtracking function is the input array. The second parameter of this backtracking function is target. The third parameter of this backtracking function is the current summation, which is 0. Because at the beginning of the backtracking algorithm, our current summation is 0, or our temporary list does not contain any other element. So we can say that our current summation is 0. And the starting position of our backtracking algorithm, which is the 0. Another parameter is our temporary vector, in which we will contain the temporary list or temporary result. And finally, our resultant vector. Now, in each call, at first we have to check whether our current sum is equal to target or not. If it is, then we have to simply insert our temporary vector into our permanent result vector. And after that, we have to check another condition. If our current sum is greater than the target, if it is, it doesn't make any sense to explore the decision tree further, then we have to simply return. Otherwise, we have to use a loop from the starting position to the end position of the input array. And in each iteration, we have two choices. Either I can take our current element or I can completely ignore it. If we take our current element, our current summation will be sum plus candidate I, because we are adding the value of current element with the sum. And we can also recursively call the backtracking function from the same element again. So we are using I here. If we cannot take any element repetitively, then we have to call the backtracking function from the next element. In those cases, we have to use I plus 1. But as we are allowed to take one element multiple times, so we are considering it only I, because by doing so, we are ensuring that we can take our ith element or our current element one more time. Anyways, I can simply ignore our current element. So by doing so, we can simply pop our last element from our current temporary vector. And at last, we have to return the resultant array. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of 2 to the power h, where h is the height of the tree. And space complexity is also big O of 2 to the power h, where h is the height of the tree. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.